Do you ever wonder how large-scale applications manage not to miss an error in any of their many microservices? Well, part of building large-scale applications is thinking about monitoring. And implementing good monitoring might just make you a better developer and help you stay ahead in your tech career. Now let me explain why. Okay, so you've built your microservices and they're all working great, but you encounter a bug in any of your microservices that trickles down and that spreads across multiple microservices, and you can't quite figure out where it comes from. I have this example here, which is an online store microservices architecture, and it has many microservices. It has a microservice for analytics, product catalog, user management, and this is not even encompassing everything that goes into an online store. But the part that I want to focus on is here, order processing. Now, whenever a new order comes in order to process the order, there's a few steps. And this microservice does all of those steps interacting with the other 4 microservices. Now the first step is check if there's any stock for that order, then process the payment, then initiate the shipment and send confirmation to the user. But what happens if, for example, processing payment fails? Well, the user is going to see failure to process order, but they're not really going to know why. But if you only have the UI error of order failed, trying to figure out why it failed, you have to work backwards if you don't have any monitoring. For example, you might be checking, is the backend actually working? Are all the services online? And then try to retrace the events for that order. And then you might figure out, okay, the payment processed for some reason. For example, this database was unavailable for a couple of seconds. The payment was not processed. And then you know what the issue was. But if you have good monitoring and any of the steps fail, then ideally you would figure out that something's wrong in your system before an error actually happens. And this is why monitoring is very important, especially for large scale applications where you have millions of users. If you have a monolithic architecture, finding an issue might be as easy as just shelling into your server and trying to tail the logs or searching the logs for the error that you encountered. And I have an example here of the online store with the monolithic architecture, and the business logic here, that's all on one server. And you can shell into it and you can look at the logs, search inside and try to figure out where the error came from. But companies nowadays that have serverless microservices architecture, they might have many different microservices, potentially even hundreds of different microservices in one company. And each of those microservices might have a lot of different Lambda functions or any other places where an error might occur. And you can imagine how monitoring all of that might be challenging, because we can't just shell into our server anymore. We have hundreds of different Lambda functions and they're all serverless basically, so you can't shell into them anyways. And that's actually one of the downsides of microservices, that it brings in operational complexity. And this is a prime example of that, where you have to monitor all of those different microservices and the serverless architecture. I'm not talking about system reliability here because I'm just a developer. I'm trying to describe what monitoring looks like from a developer's perspective. And because we built all of these things, we need to think about how they're going to be monitored. And the goal of your monitoring is very important here, because depending on what you're trying to monitor, the implementation is going to vary. For example, you might be trying to monitor how to best debug any issues, or how to set up alerts, when anything goes down, or if you're trying to monitor performance bottlenecks in your systems and containers, whatever it might be, these are the things that's going to determine what you need to use for that monitoring goal. And this really comes with anything that you're trying to build. Depending on the goal you have, you might not need to use all the sophisticated tools I'm going to mention in a minute. You might just need to set up a pinging method to see if your microservice is alive or not and alert you when it's down. And there are many different monitoring metrics that you might be interested in, again, depending on your goal. These are some examples of monitoring metrics. For example, latency response time. These are very important if you're trying to figure out how fast your services are, how fast the user is going to get a response. Error rate and error metrics are very important metrics in my opinion, because they actually give you an idea of how many errors are occurring. Some of them might be user errors, some of them might be code errors or logic errors, and that's where the specific errors come in place. So you might be monitoring a specific error, for example, unable to write into database, And you might set up alerts for whenever this error occurs, send alerts to the team, and then the team can investigate. With this in mind, if we go back to our microservices architecture, and like we said, if the payment processing database fails for some reason, let's say this is down, if we have monitoring for the uptime of the database, we're going to be notified when the database fails. And in that case, we know where the errors might occur. After that, we're probably going to see order processing fails or payment processing failed errors. But we know the first error that we saw was that the database was down. And this is how these metrics can help you to identify the problems. You're not working backwards and trying to figure out where the issue came from, but you have these metrics to correlate and see where the issue comes from. And believe me, metrics like this have saved me so many times trying to find an issue or actually preventing issues. For example, if you have an EC2 instance in AWS, one of the more useful metrics is the CPU load of the EC2 instance. If it goes above 80% or 70%, get an alert saying that the EC2 instance might get overloaded. And if you don't have auto scaling set in place, this is one of the key metrics you need to look at to make sure that the website doesn't go down and the EC2 instance is not overloaded. Now, there are many different examples I can come up with and the many different metrics that you can set up for your systems. And again, if your company has SRE teams, this might go to them. But as developers, we need to make sure that we're logging good data, we are setting up alerts, we're looking at metrics like error rates, and we're setting up alerts for specific errors and error rates, because these are the things that are going to help us to actually find the issue. Now, because microservices in nature, they are distributed systems and they might have logs for every different microservice and every different Lambda or container or whatever you're using. They might have different logs, and aggregating all of those logs in one place is important. And this is going to help having all errors in one place to make sure that you can find the issue and not go from microservice to microservice in different logs all the time. And there are tools that can help with that, like Datadog, Prometheus, or New Relic. And AWS has its own CloudWatch logs. And I'm sure all the other cloud hosting like Azure or Google, they have their own monitoring and logging service. But like I said, having all of those logs aggregated in one place is really going to help you if you have microservices architecture. And after we have all the aggregated logs in one place, we also might need to aggregate our metrics. Looking at all the databases that we have and all the different EC2 instances we have, how they're behaving, some of the metrics that we're looking for, if we aggregate them all in one place, we can set up dashboards and monitor all of these different metrics in one place. And again, this is crucial if you have distributed systems or microservices. Now, third thing I want to mention here is setting up alerts on all of those metrics and logs. Whenever you see a specific error, like I said, maybe unable to write to database, having those alerts is what's going to tell you you have an issue that you need to be looking at. Because if you just have the dashboards and the metrics, nobody's really going to be looking at them all the time to figure out if there's an issue. And all of those tools like Datadog, I've only have experience with Datadog and a little bit of experience with Sentry, but Sentry is a bit different. But my experience with Datadog is that they offer alerts, and you can put alerts in place to make sure that you're alerted when everything goes wrong or something unexpected happens. And the last thing I want to mention is if you're looking for debugging any errors, tracing is crucial to make sure that you can figure out where the error came from and trace all of the events that happened to that error. Again, I'm going to go back to the microservices architecture here. Datadog offers good tracing tools where you can see when an event comes into the order processing microservice, you can trace each of these steps and each of these requests to the different microservices and how they've been handled if there was an issue, which is great to understand and debug where an error comes from, why it happened, and how to replicate it. Now, of course, with all of these things that I mentioned, it's very important to have good logs and good alerts, because all of these tools like Datadog and New Relic, they all have costs associated with them. The more you log, the more data you have, the more you're gonna pay. And logging only the important information, which is not gonna be too much, but not too little to not figure out what the issue is also very important. And this is gonna come down to your system and what you're looking for in order to figure out if there's issues or debugging. But there is such thing as too many logs, and there is such thing as bad alerts. For example, it might be a user error that you're alerting for, and there's nothing you can do about it. And the people that are looking at these alerts know that most of the time the alerts are to be ignored, which is a problem, because then you might have an actually good alert where it's an actual issue that needs to be looked at, but people are just going to ignore it because of the noisy alerts. The important thing to remember here is monitoring can have many different goals and many different things that you're trying to monitor, and this is going to determine what are the key metrics you want to look at, which tools you want to use, what are good logs for your goals, and what are good alerts for the goal you have. It all comes down from that, so make sure that you have good monitoring goals, and I hope you understand the challenges of monitoring microservices and serverless architecture. But yeah, that's been pretty much it for this video. Thank you very much for watching. Enjoy the rest of the day. Happy coding. Bye.